Okay, in this video, I'm going to do a regression with one covariate, that's just a quantitative or continuous explanatory variable, one factor, that's just a categorical variable. In this case, I'm just going to have one that has two categories, and then the interaction. My covariate, I'm going to try and predict, I'm using a college data set, I'm going to try to predict graduation rate as a function of my covariate is the number of students who graduated in the top 25% of their high school class, and then my factor is going to be whether or not the school is private or public. So anyway, the first thing I'm going to do when you do an interaction is you're going to want to center the covariate. So I'm creating a variable mean top 25, which is just equal to the mean of the top 25%, and that is 55.79. And then I'm going to create a top 25 centered where I take each individual value of top 25% and subtract the mean. Okay, this next part you don't necessarily need to do, but I'm going to go ahead and do it here. I'm just computing the mean of the top 25%, and I'm going to just bind the original values and the top 25 centered. And what you can see is for each of the original values, like here's 66, if you would subtract that mean, it's 55.79, you'd get 7.2. So when you were up here at 50, you subtracted 55.79 and got minus 5.79. So this first column is just the original values that were in the data set. There were 777 of them. That is the original values. And then the values in this column, the values that we're going to use in our regression model, are centered so 0 is going to equal the mean of the data set, or the 55.79. Again, that's just to show you what the top 25 centered variable is, what we mean by that. Just subtract the mean from each value in the data set. So now I'm going to run the regression line, and you can see here I have my model. I called it interaction C for centered. LM equals graduation rate. That's my response variable. Tilde, and the order doesn't make any difference. But there's my covariate, my quantitative continuously measured variable, plus private, which is a dichotomous or two-category categorical variable, binomial variable, private or public. And then my interaction, you take the two variables and put a colon in between them. Okay, that's just doesn't show up that well here because of there we go. I'll stretch that out so you see there's no spaces in that. You can put a space here or not. That doesn't make any difference. So I'm going to run the model, and then I'm going to have the summary of that model. And so now I have my intercept, my top 25 centered, the coefficient for that, and then the coefficient for if you have private, and then here is the intercept for the interaction. The reason you don't have, I don't know why they list this on here, you don't have the other one here is because you only have two categories of the variable, and so you just list it for one. And you'll see in some other things that we might do in some other programs that instead of getting the 0.42, you'll get the 0.42 minus this. It's about 0.30 or 0.31, something like that. And that's the regression model. And I think when it comes to doing an interaction model, it's almost prerequisite that you do a plot of the data so you can understand it yourself and explain it to somebody else. And I will say too, if you use if you did an interaction between two continuous variables, you want to run your regression model that way, but when you go to graph the data, do some kind of split, maybe divide your continuous variable or one of your continuous variables into 2, 3, or 4 groups, maybe a median split or split by quartiles, and then do the kind of graph that I'm going to do right now just to get a better understanding of what's going on. Another approach would just, if it was a discrete variable, would just be to select some specific observations. But I'm getting off the topic of this particular one. We're just going to plot graduation by top 25 centered, and then I'm going to, so I'm just plotting that, and you can see I've got green and blue, and this says I want to, by putting the square brackets with private, that means I want to get colors for both green and blue, one for private and one for public. And so now I'm going to put a line on here for graduation rate when private is equal to no, times top centered with private equal to no, and I'm going to color that line green. And then I'm going to do the same thing for when private is yes. Oh, okay, so I didn't get the whole thing. There we go. And so now we have the lines for the two, where the top line is for private schools and the bottom for public. And you can see when we went back up there, the interaction was slightly significant, as was having, the top 25 centered. So in both groups, the higher the proportion of top 25 graduates from high school, the greater the likelihood that they will graduate. That kind of makes sense. And then the interaction being significant means that that relationship is different for public and private schools, and it looks like that the slope for public schools is a little bit less. Maybe there's other factors that come into play there, and then a slightly higher slope for the students that go to private schools. It may just be that if you spend more money, you're going to have a higher slope there. Well, who knows? You can try to explain that on your own. But anyway, that's how to run a regression with one covariate, one factor, and an interaction. And then make sure you plot the data to supplement the model that you come up with there. I would encourage you to run this in other packages as well, like SAS or SPSS or Stata, and kind of compare the results across the approaches.